Speaking of energy priorities, we've done a lot of work on electrification planning, electrification demonstration, and electric vehicle deployment. And I'm really excited to be connected with Van Wilkins of In Charge and to be passing the microphone over to Van for an introduction. When I speak and hear from Van, I am connecting with an individual and an organization with a deep focus on the future and a surprising set of accomplishments. Van might talk about just a few of those today, but I'm just so super excited about heavy duty vehicle collaborations, electric school bus collaborations, infrastructure collaborations, and getting a bunch of people to check out In Charge facility in the future as charging infrastructure demonstrations are available. I actually just brought it up earlier today on a call because I'm just so fired up about it. This is really important because many people may have never seen an electric vehicle charger or may not know what the technology installation profile might be needed for a medium duty vehicle or for the top end spec of the J1772 charger. So I'm really excited about hearing from Van, and this connection is great. So without any further ado, Van Wilkins. And you're on mute. Okay. Yeah.
Well, I appreciate it. Just share a little bit about myself. I started my career back in the 80s doing gas stations and fleet fueling. Back when we had a hard time getting 2 card readers to operate the same diesel pump up and down Commerce Road and up and down the Appalachians. So it's kind of funny. I've just changed fueling types. I've gone from liquid fuel to now electric fuel, but it helped because a lot of fleet fueling problems back with the old school buses, it's all just coming forward now. It's just a new fuel type. Most all the industry went through this in the 80s because they had to redo all their fuel pumps and tanks to meet the new EPA regulations. So that's what we've been talking to fleet operators for. This is just another round of regulation that you have to make an adjustment in your infrastructure to do. I was doing a conference yesterday for the school bus operators group in New Jersey. They're commercial fleet operators. So some of the information I have is labeled for buses, but it's pretty much applicable to all. And I want to just kind of focus on the key difference in charging type, AC or DC. And to give you a little history of how things have kind of evolved. The early vehicles back, we'll say the Nissan Leaf in early 2010, 2012, only could do AC charging. Then they had the CHAdeMO, the DC charger. But most all the vehicles were set up to charge around what you had at home. They want to be able to plug in at home. A lot of our charging infrastructure is based around that key piece. So I'll just to give you an idea, the first question always comes up is, how do we pay for all this? Well, to pay for it, you kind of have to understand a little bit about the way charging infrastructure works and the need. So this kind of graphic shows you got to connect to the grid. You got to connect to utility. You have to connect to an energy source somehow. And then you have a panel you have to distribute to breakers and switches, conduit, pipe, and wire to take that energy and connect it to a vehicle. So funding it, there's different buckets of infrastructure here that you have to take care of. And that funding piece really depends on who's going to make it. If it's going to be the utility, give you some money, if it's going to be facilities, or if it's going to be the fleet operator itself. Now let's talk a little bit about infrastructure. And first, let's think about how a vehicle charges. So what everybody calls a AC charger really is not a charger. It's a switch or a contact with a controller on it to bring building voltage to your vehicle. Actually, on the vehicle itself, as you can kind of see here from the graphic, is where the charger is. That charger determines how fast the battery is going to charge based on what comes in the vehicle itself. They're not all the same size because it adds weight, it adds cost, and people have different battery technologies. So the chargers are not all the same. Really, what you're doing is saying, hey, from the building, and you can take all that power to do whatever you want to with it. You plug it in, the vehicle says, hey, we're ready to take energy. Charger says, okay, great. And you'll hear sometimes the older ones, you'll hear them go chunk, they'll clunk in as the switch closes. Then you're feeding power to the battery charger on board. And then it's putting a small amount of voltage to the charger itself, to the battery itself. Now on the other side, you see DC charging. This is actually a charger. You're converting your building voltage or your grid voltage, and you're raising it up and down to match the voltage of the battery in the vehicle. To give you an idea of why this is so important, a Tesla has a 350 to 375 volt battery. A Porsche Taycan has an 800 volt battery. The new Hummer has an 800 volt battery. A Mach-E has a 500 volt battery. So it's all over the place. So the DC charger allows you to change the voltage up or down and give you more power faster because it's putting it right to the battery. And then the only limiting factor is the size of the wire from the car plug down to the battery and the temperature monitoring system on the battery itself. So that kind of slows it or speeds it up and down so the battery doesn't get too hot, the wires don't get too hot. Now, why that's important, because AC charging is slower, but you can plug in anywhere because you can plug into an outlet at your house, but you'll only get a couple of miles an hour worth of range. Whereas the DC charger is faster, a little more efficient, but there are some drawbacks to that because you're getting a big chunk of power that not everybody has available. If you have any questions about AC or DC charging as we go through, feel free to ask it. From a plug standard, if you look at the types of plugs involved, you have Tesla has a plug, Rivian has a plug. You've got the kind of North American standard, the J1772. And those are all the AC kind of charging standards out there. Then there's another three-phase one that BYD and some European companies use, but for the most part, everything is the same standard, that J1772. It's 2 wires and a ground, 2 hots and a ground. So you basically plug it in at home and then some control wires. When you do the DC, you have to have 2 big, larger wires for the DC charging, and the plug that most people use just puts the DC ports right underneath it. So in that one spot in the vehicle, you can do AC or DC. The old Nissan had 2 separate plugs, one big fat one for DC and another for AC. So there's different costs and all associated. So you can see why the manufacturers want to get down to one spot on the car, one hole, one opening, one plug. Now, from a hardware standpoint, it kind of falls into 2 basic categories. You're either going to do AC charging for a vehicle or DC. And when you do AC or DC, it's really about how much power you have available. You have limits, a smaller limit on AC charging. So usually people break it into level 1 and level 2. And it's going to kind of sound odd, but some people also call it level 3. And it really goes back to how people look at electrical. They see 1-phase wiring as level 1, 2-phase wiring as level 2. DC charging is level 3 because it's almost always 3-phase power you need. It doesn't really have much to do with the actual charging speed. On the AC side, you're doubling the power, but it's still incremental. But AC charging is usually, and this is on a bus, to give you an idea on a heavy vehicle, if you plug into a regular wall outlet, say the bus pulls up, stops at a 7-Eleven, no place to charge, so it pulls the drink machine out or the refrigerator and plugs in the vehicle. About a mile an hour of range is all they're going to get. In your personal driving vehicle, you might get about 3 miles an hour at most. So it's not a lot of juice, but if you're not going that far, it's no big deal. Then you move into what most people are used to with the level 2 AC chargers, like the charge point chargers, the Clipper Creeks. This is really a matter of, usually it's a 30 amp or 40 amp outlet. The maximum outlet that you can do is 100 amp. That's the 19.2 kW charger. Now, what's interesting, because everything in the US is set up and based around residential voltage, we do single phase charging. In Europe, you can get 3-phase at your house on a regular basis. So they use a little bit different standard, and they can do higher AC charging than we can. They can do 22 kW. Some of the vehicles do 43 kW. But more and more, all the vehicle manufacturers want to shift to DC charging. Why? They get a part off the truck or off the car. They can throw it away. You don't need it anymore. So they make more profit, less weight on the vehicle, less complication. But it's going to take some years to get there until small, compact residential DC chargers can be made. So for a long time, there'll be something on the vehicle so you can plug it anywhere. Now, these AC chargers, even if I put in we'll say a 19.2 kW AC charger, Can all vehicles charge at that speed? What do you think? You're right, because it depends on what they have as their onboard charger on the vehicle. You know, if I pull up and I've got a plug-in hybrid, they usually have only a little 15 amp onboard charger. If I pull up in a Tesla, Taycan, maybe a few others, they might have dual onboard 40, so they could do 80 amps. But most of the average vehicles like the BMW i3, the Bolt, can only do 32 to 40 amps, no matter what size AC charger they plug into. Now we get to the DC where you get a lot more power, but so like the older Chevy Bolts would really kind of cap out 50 kW, 80 kW. Even though they could charge faster, the engineers decided to, hey, we don't want the batteries to get hot. We get the most life out of them. So they kept the charging rate kind of low. But still at 50 kW, that's 80 miles an hour range. It's, still a lot of power that's available to them. Now, in the DC charging, you kind of have some step ups. So sometimes we'll call it low power DC, mid power, and like high power charging. So have any of you seen the stations that like Electrify America has on the interstate? There's a couple of them down 81, a few of them, depending on what part of the state you're in. A lot of times those are the 350 kW, the high power charging. They have a liquid cooled cable. Otherwise, if you had to do a 500 amp cable, it would be about this big. And trying to pick it up and plug it in the car, it would fall out, it would break. So they do liquid cooling to keep the cable small and lightweight. A lot of complication, but it allows you to do 500 amps. So it gives you the same amount of power in a short period of time as most buildings take. So you go to like your average grocery store, you look out back, that big transformer is equivalent to the same amount of power that you're going to charge the car up fast. That's why a Taycan can charge in like 15 to 17 minutes, because it's taking a very high voltage and it's taking 400 or 500 amps all at once, like the new Hummer is going to do as well. But if you're doing fleet fueling or a lot of vehicle charging, this makes more sense because you're trying to get as many vehicles through a space as possible. Because sometimes property is more expensive than the electricity. So if you don't have many parking spaces or you're trying to move a lot of vehicles, you want to be able to charge high and fast. And people say, oh, well, what about the demand charges from the utility company? Well, you only pay the demand charge once a month. So once you pay it, you want to get as most use out of as you can. If I turn on one of these chargers and I pay $1,000 in demand cost, if I only charge 1 or 2 cars, that gets expensive. So the more utilization, this is why EVgo and others struggled for years with fast charging, because they didn't get a lot of usage. So you pay the $1,000 for turning the charger on once that month. And if you only have 10 people use it, it's $50 just to pay the demand. And then you have to pay the other electricity. So the market wouldn't really support it, especially when you can, most of the time, most all of your driving, you can just plug in at home on the AC charger. So utilization is the key to making DC chargers work for like a gas station owner or parking lot or anything. They need as much as possible. You have a question, Alan?
Can you go over that one more time? So in order to gain the maximum amount of electricity at a gas station, so that came up earlier this week, or at a site with lower electricity, maybe throughput, how do you bring the costs down? We're all hoping for $1 per kilowatt hour, dollar per gallon equivalent, or 12 cents per kilowatt hour. How do we keep it at that rate? Will you just go over that one more time about the demand charges?
Yep. Think about it in terms of a pie. You get a pie. If you have only 3 of you, you all get big chunks of the pie to eat. So if the pie costs you $1,000, there's 3 of you, each of you are paying $330 for your slice of the pie. If you get 10 people, now everybody's down to just $10 a slice of pie. If you get 100 people, now everybody's got $1 slice of the pie. So it's really about the more people that use the charger in a month, the better. That brings the cost down. So that's why sometimes where people, hey, I really need a charger out in Montpelier. Well, there's only 5 electric cars out there. That's an awful lot of infrastructure to charge 5 cars, maybe 3 times a month. So when they cite a DC charger, unless there's public money doing it, or unless it's being done because a business is going to generate a lot of revenue off of those people being there, it doesn't make financial sense to put a charger where there's not a lot of usage. Because if you have the choice of, I'll adjust my trip, or I can just plug in at home for, $9 and I fill up my tank, or I go out on the road and I have to pay $50, the market drives that really fast. So that's the key to DC charging, because there's a lot of infrastructure. It's a heavy cost. If you think of it in terms of a dollar cost to put in a charger that can charge, say, an e-tron in an hour, to put that charger in the first time, the cost of the charger and the installation is usually going to be about a minimum of $80,000, everything all in. So you start looking at how many times do I have to plug in a vehicle to pay off $80,000 when electricity is cheap. There's just not a lot of margin on electricity because it's only, in the state of Virginia, 10 to 14 cents per kilowatt hour. So you look at, hey, on a really big battery, there's only $14 of energy in the tank. That's not a lot of money. And you look at the average smaller car, now you're talking $7 of energy. There's just not a lot of money there you're dealing with. So there's not money to be made really in fueling when the utility company is already kind of charging low anyway. And so that's kind of some of the challenge. In this case, the commodity supplier is already selling direct to the public. So you can buy it at home for 14. It's kind of like going down to the 7-Eleven, buying a candy bar, and then going next door and selling it to somebody. Well, I'll just go next door and buy it from the 7-Eleven. And so that's kind of the challenge with DC charging right now. There's not enough vehicles out there to drive the utilization up to pay off the asset. So when you look at the cost, I can do a level 1 charger that comes with the vehicle usually at home for nothing, just the cost of the electricity. I can do a level 2 charger. You can get those off the internet for $200-300, $1,200 to an electrician, whatever, to put in a 50 amp outlet. And so that pays it off quick. If you were to put a 24 kW DC charger at home, you're going to pay about $7,000, $10,000 all in, install permits and everything. It takes a while to pay that off. You have to really want it, or you got to be doing a lot of range where you only just want to fill up at home, which you could, but it's a lot to pay down. So, stretches out that return on your investment. That's why the DC charging right now is really being driven for the public, has to be public money, because there's no money in it for anybody. It really just has to be something they want to do. Whereas with fleets, now I've got a lot more fuel to kind of drive my utilization up. So it's worth the gamble for somebody to put a charger in for a school bus operator, or for the bread truck guy, or for a package delivery company, because they know they're going to buy a lot of fuel and be able to pay it down fast. Is that kind of?
And Van, that's what I was going to suggest, is especially not just the unit itself, but the whole subject of demand charges kind of changes when you're talking about a fleet, because you're going to have a certain amount of demand each month. And as long as you don't drive that demand charge way up by plugging them all in at the same time, that's another element. But it seems like because you've got the predictable load, or somewhat predictable load, and also as you talk about medium and heavy duties with higher loads, it becomes a completely different calculation than it does for public light duty recharging.
Yeah. Excellent point. And now I wanted to kind of highlight another, when you're talking about residential, we'll say commercial passenger vehicles for consumers, it's an entirely different calculation because you can plug in at home. Hey, if you can't get anywhere, you call a Lyft or Uber, you call a buddy or a friend, and you get a ride to the store wherever you're going to go. But for a commercial fleet, if their vehicle doesn't move, they don't make money. So the need to be on the move every day drives up the value of having to have their fueling be resilient and responsive. Now here I want to kind of illustrate the difference, because a lot of the school buses have started out being AC charging, or some of the package vehicles, or some of the small fleets. They're like, hey, we'll just put in a bunch of AC chargers. And that can be okay for the first couple. But at a commercial building, there's a difference, and it's kind of highlighted here, but we'll look at it as voltage. If you look at a building that only has 208 or 240 volt, a high power AC charger, one of those 80 amp, the 19.2 chargers, and it might cost you 16 grand to put it in with extended warranty, permits, fees, and everything. As you move into a DC charger, a small DC charger, like a 24 kW, you can charge faster, but there's a little more cost to it on a smaller service because you got to, if it's 208, you got to put a larger wire, larger pipe. So that the cost is higher on a DC charger on a, we'll say a small commercial service. If you move into a building that has 480 volt power, now, because I can do smaller wire, smaller conduit, and now it's a lot cheaper to put in the DC charger there. It's still price wise, I get down to about, it's going to be pretty comparable, equal to a high power AC on a commercial building versus low power DC. But where you really get the payoff is where I have a max 80 amp charging on the AC, I can do 24 kW on the DC. And to give you a little idea of the nuance, so a lot of times you'll hear manufacturers say, hey, we sell a 19.2 kW charger or a 7.2 kW charger. They list it based at its highest possible voltage, which is residential voltage, which is 240 volt. Commercial buildings, it's 208. So that 7.2 kW charger on almost all commercial buildings will only be a 6.6 kW. That 19.2 kW AC charger really is only a 16.6 kW charger on a commercial building because the voltage is lower. It's 208 volt, it's three phase, it's lower voltage. So you actually, now you see if I have the choice of a 16 kW charger or a 24 kW charger, costs the same to put it in, which one would I want to do? I'm going to go with, I get more money per kW, better value per kW. And that's really what the, on the right-hand side, you're kind of seeing is, if I look at cost per kW of charging, what I pay per kW for a 480 volt, is a 30% difference versus a high power AC. And part of the reason is, if you think back to our first slide, you have the utility. Most commercial buildings, they have a transformer, 480 volt, then you step down to 208 for your receptacles. Well, the transformers are not sized for a bunch of car chargers. I can usually maybe put in one in a commercial building without any upgrades. But when I start adding 3 or 4 ports, now I got to set a new panel, a new transformer. So I bring the voltage in up here, I step it down, take it to the vehicle so the vehicle can bring it back up for its battery. So that extra transformer panel and bigger wire starts just making it not worthwhile. So if you've got 4 or 5 vehicles, you really want to do low power DC. Now you get more bang for your buck. You can charge your vehicles faster. It doesn't hurt the battery because you're not heating it up. You're still doing lower power, and you're bypassing the onboard charger. So you're just putting juice right to the battery. So when people are looking at their fleet, this is really, and a lot of it comes because a lot of the manufacturers, not many people make a low power DC in North America. There's really only 2 that are making them at scale, Delta and ABB. They make a 24 kW DC charger, mounts on the wall. FSAC has one, but it's the size of a desk. It's huge, and they don't really make it at scale. But those 2 companies, Delta and ABB is the only one making the higher voltage unit that works with the Tycon and some of the others.
I'm just going to make a quick commercial here. The Commonwealth of Virginia does have a incentive with EVgo that's deploying some of the DC fast chargers, and municipalities or someone willing to make a public DC fast charger that 25 kW might be able to get it just by communicating with EVgo due to that grant and program. So if you're suggesting that technology and someone's interested, I would suggest they contact EVgo.
And that's from a, we'll say a utilization standpoint, ABB is one of the ones that that EVgo uses a lot of. So to give you an idea from a size standpoint, just when it kind of ranks, you can see, we'll say on we'll say a large vehicle like a school bus, something that does a lot of work, 300 kilowatt hour battery. And this is why you can see why it would be important. to get 150 miles of range out of a big vehicle, you need about 300 kilowatt hours. So now you start looking at how long that takes on an AC charger. I'm sitting there 16 to 18 hours. So if a school bus has a short range, okay, yeah, it might only need to charge 8 to 10 hours a day. But if it's got, if it's running morning and night, it doesn't get to park during the day, you run out of time to be able to charge a vehicle every day. So you spend all this money building all this infrastructure for AC chargers, and now you're peaked, you're capped out. If you ever get new infrastructure come in, or as chargers get smaller and less expensive, now you're kind of hemmed in because you went with a technology that's only going to go higher than the small charger on the bus or on the truck or on the car. Whereas if you set up the infrastructure for 480 volt, 3-phase, now as they get new technology, you got a lot more flexibility. You can just change out what's on the end of the circuit for something newer and greater 5, 6, 7 years from now. As that same size battery, now you go down, look at that 24 kW, now you're down to 12 hours, 50 kW, 6 hours, and you can see on down. In case of school buses, they haven't all gone where they can charge above 150 kW, we'll say, because it's bigger wire, and they have to take the wire from the front to the back of the bus, so it's more cost. So some of the decisions about how fast a vehicle will charge are driven by the cost of the vehicle right now. So if you say, well, why can't they make a school bus or something charge faster? Or why doesn't my Leaf charge faster? Why doesn't my Bolt charge faster? Larger wire is needed, which is more cost. Higher, more metal and components for the contacts. So a lot of it's really a financial decision on charging speed when they look at how people use the vehicles and the payback on it. There are induction chargers and things coming, but those require an investment on the manufacturer because they have to add a coil to the bottom. So that's one of the drawbacks to wireless charging, is it adds cost to the vehicle. So whereas on some heavy vehicles and as a premium, people may do wireless charging, it's going to be a long time before it really gets adopted, because now you have to add another couple $1,000 to the vehicle to do the wireless charging pad. So now you'd have an AC charger on board, you'd have a wireless charger. So now you're adding, you got $5,000 in just charging infrastructure on the vehicle, and now you've added more weight. So for some use cases, wireless charging would be great. People can pull up, but there's a cost and weight limitation that's going to be a while before it becomes widespread adopted. It'll work on some of the fleet vehicles and heavy vehicles where there's problems with, well, where do I plug in at? And I can pick up a lot of savings on how we operate it if I can just pull over a pad and the driver can walk away. So but there's some exciting things happening with wireless charging, but just it has a ceiling at the moment because it adds weight and cost to a vehicle. And manufacturers like, well, we already got one charger on board. I don't want to add this other one unless somebody wants to pay for it.
Yeah, Van, we've been seeing some interest in inductive charging for transit buses. That seems to be the one sector that seems to be out front as far as interest. And we actually just did a system with Martha's Vineyard because they wanted some in-route charging. So
yeah, it's there's
seems to be the one sector.
Yeah, and because with the buses, they either have two choices. They can do the overhead pantograph, and some areas don't like having this 20-foot thing hanging up in the air, and it adds cost and infrastructure, whereas an inductive pad technically could be cheaper, but then you got to worry about, they have to cut up, they have to put it, and you still have to add something to it. But transit buses are all federal money, so it's a lot easier to cover them there.
Yeah, well, the idea being the pantograph is fine if you're talking about a depot, but if you're talking about, say, a bus site, like, even at a subway station or something like that, where the transit operator owns the property and can put it in the ground easily, the pantograph just, may not work for that.
Yeah, we're doing we're starting up some systems. We put the bus chargers, did the startup on them at Alexandria. They got the electric buses, and now they're using new Flyer and Proterra. We're doing a system for Lake Tran right now in Cleveland. We did probably one of the largest ones kind of going on right now outside of California. It's been in Missouri, surprisingly enough. And they put in about 10 overhead systems and about 50 depot chargers. So St. Louis, Missouri's got a really nice system going. So it's been interesting.
What kind of system did you put in for Alexandria?
They're just doing standard depot style plug chargers.
Okay, that's what I thought.
I mean, and you look at the size of their district, it's not very large.
No.
So for them running their routes, they can just all come back to the depot. And so, I mean, you can see that there's a lot of ways to approach charging infrastructure. You can do things different with a EV that you can't do with liquid fueling. You can plug it in and walk away. So it does give an operator more flexibility on how to use the vehicle. And right now you have to stand there for 5 minutes to fill up your car, whereas for the EV, you just plug it in and go in and do something else. So there's change in patterns. Same thing with fleet operator. Now, there are some fleet challenges in that some people, the way they fuel their trucks and buses and things now is they have a big tanker truck drive in, pull up, and dump fuel individually into every vehicle. So that's a little bit harder to do with electricity because of the transfer rate and speed. And it takes up more space to store electricity than it does liquid fuel. But it's something that people are working on, but there's some challenges there.
Van, I just had a quick question, possibly quick. You mentioned the 100 amp. So there could be a pin and sleeve for 100 amp charger installation. So you would still need to have the plug of the charger, like the side that connects to the wall, with that pin, and then the other side there'd be a sleeve connector. And is it sort of like a, some sort of cylindrical thing? Is that okay?
Correct. Yeah, and it adds its expense, and it's usually you only use the pin and sleeve where you're going to be changing chargers out a lot.
Thank you very much.
That's usually the only place you'll use it. So, in another reason why DC charging can be a little more viable for people, because it gives you flexibility on how you move energy around. So on the screen, I kind of have we'll say the dream scenario. You've got the vehicle, you can feed it from solar, you can feed it from the grid, and you've got batteries to store energy. 100 years of fueling vehicles, we've narrowed it down to the system that works. You store energy close to where you dispense it. Farmer has a tank in the ground or a tank above ground. There we go. So here you have kind of the perfect scenario of, we'll say, fueling in the future and what people are developing now. The batteries are my storage tank. That's my gas tank in the ground or above ground. When you can store the energy, then you can dispense it out quicker. You can fill it up from solar, wind, hydrogen, however you want to make it, or you can get it from Dominion Energy, Southside, Central Electric, whoever. But you store the energy where you need to dispense a lot of it fast. And that gives you more flexibility in cost, price. If the grid goes down, you still have some energy stored, but you kind of control it. And that's the beauty of having your own fuel tank. That's why, like at home, people are getting the Tesla Powerwalls, because now they can store the energy they make and decide what to do with it. I can save it for backup power, or I can use it when the rates are expensive and fill up my car. So storing your own energy is valuable. It's why we go and buy packaged foods to go on a hike, because you can store, it's portable energy. You can take it where you want to, and you eat a candy bar when you need to, as opposed to having to grow it and raise it. It takes time. So you want to have portable energy that you store. So that bi-directional flow, the vehicle has kind of limited value, except maybe in a power outage, because there's really not a lot of energy in your car or in your truck. To give you an idea, a school bus, most of the school buses right now, diesel school bus gets 6 miles to the gallon. That same 1 gallon of energy takes a school bus on electric 28 miles. So the average electric school bus really only has like a 6 to 9 gallon diesel tank on it. So when you start looking at how big the diesel tanks are on generators to make electricity, they usually have like a 200 gallon tank. So there's really not a lot of energy that you're carrying around. Doesn't take much to motivate a vehicle on electric. So its value for vehicle to grid can be limited. And that's why I wanted to just kind of, let's see here. So when people ask about vehicle to grid, now DC charging allows me to do bidirectional much easier than AC, because I can control the voltage back and forth. But when you look at the comparison, like a school bus, which you think of having a really big battery, imagine walking up to a building or to the utility company and say, hey, I've got 2 5-gallon gas cans. I want to sell them to you. it's not really that sustainable. Yes, early on, they want to experiment, see how it works. For the early adopters, they'll throw some money out like Dominion did with their experimental program. But long-term, you can see where that, yes, if you have 1,000 buses, okay, great, that could be aggregated and now it makes sense, but still it's 1,000 10-gallon gas cans. It's much more easier for a utility company at scale to buy their own battery packs and put them in somewhere. And then if you look at the cost of the hardware to do the bidirectional, a 60 kW charger like they use for that Dominion program costs $60,000. I can buy 2 chargers for that standard charger. So I get 120 kW, charge 2 vehicles and pay less. So there's so much money involved in bidirectional charging infrastructure. Remember how we talked about there's not much margin on electricity anyway? So, you know, hey, I buy it at 15 cents, I store it, I sell it back at 3 cents, and then I have to fill back up at 15 cents. There's just not much money there. So vehicle grid can be great for early adopters. It can be great for emergency backup power when everything else is down, but it's not really something that you want to count on being able to make a lot of money on. There's just not much there. And to give you an idea from a battery standpoint, so if you took the batteries inside of a bus, or if you took 2 Tesla batteries and stuck them side by side in the enclosure, you got like 2 refrigerators side by side. And that's basically what it is. You have batteries, they got power modules one side, enclosure, fire extinguisher. And that gives you the same energy as like 2 Tesla batteries. So you can see there's a size issue trying to store the energy. So you start putting these, stacking them up, but there's some value to it. But it's kind of the wave of the future. You got to be able to store some energy locally, and then it's a matter of sizing it. Hey, how long do I want a gap between my solar, the grid? But by doing DC charging, you give a lot more flexibility, because now your solar panels make electricity at DC, the battery is stored at DC, the vehicle uses DC. Instead of having to transform everything from AC on the grid to DC to put in the car, if I just go ahead and make it a DC and pass it right to the car, that's why some of the renewable technologies are a lot more simplistic. And simplicity reduces cost and also increases reliability. So those are some of the reasons why DC charging long-term is going to be what tends to win out. AC charging, as they move to more inductive charging is AC charging. You take and make a high frequency circuit at AC, kind of like think a microwave. You transmit the power over a short distance, you receive it on the vehicle, and you use that to power up the batteries to send energy back into them. That kind of gives you some of the reasons why you do AC versus DC. And I didn't want to overwhelm with a lot of information, but I want to kind of help you think about a battery stores energy in DC. So the whole goal is how you get that energy into the battery. Either slow, think trickle charge AC, or if you make the voltage the same as the battery and dump it right in. So I appreciate your time.
Dan, do you want to tease us with any information about your upcoming work in Virginia, your upcoming facility, or anything like that?
Yeah, so what we're doing is there's a new charging standard coming out called the megawatt charging standard.
I was just talking about this morning. So happy to hear you say that.
And now what it does, it raises the voltage even higher. So they take it up to 1,000, 1,500 volts, so they can send more power faster in a smaller wire. That's still a little ways out, but it's pretty close to being finalized. One of the big tips will be whether or not Tesla adopts the MCS standard or goes their own, because that'll really set the stage for how money can be invested from the public and private sector on fueling heavy vehicles. Vehicles that need to get a lot more power in a short term, like think a tractor trailer, long haul tractor trailer, think dump trucks, big heavy construction vehicles that need to get big doses of power in a short period of time, that are going to have 600 kilowatt hour battery packs. What we're doing now is we're bringing in some charger components from other places in the world to try to make them a little more made in America compliant here, and trying to drive down the overall cost of DC charging. For us, we have to have a lot of them because we know they're going to break, and there's such a need that So to give you an idea, right now I've got charger orders in with a couple of companies, and I have on order probably about 1,800 DC chargers right now, just to fill out what I'm gonna need for this year and early part of next year. And if you look at what's being done, every Chevrolet dealer in the country, every Cadillac dealer is getting a charger. All the car dealers are having them. And we don't really charge there, but it gives you an idea that if the dealers are getting ready, that means the manufacturer going to start pumping them out. The first place to go is a dealership, and then they get distributed. So there's a lot of exciting stuff happening in the fleet side of it. The passenger vehicles, because the compliance are going to come along. So we get to kind of see some of the cool stuff because we're testing new chargers. Here in Virginia, we're going to be having some of those energy storage systems to put batteries right beside chargers. And we're playing with a lot of different charger styles out there, different charger networks, and trying to optimize it. So we'll have public charging here right across from Chesterfield Town Center that people can come and play with and use and fill up. And then we'll have some of the experimental stuff inside the building. And we have a spot out back for large vehicles, because every vehicle that comes out is like a unique computer. They all like have a personality. So they have to plug them in with a lot of different chargers and see how they respond to the charging curve, because the first ones always have problems. Half time you turn it off, turn it back on, and fix it. So that's some of what we're working on. All the Nissan dealers in the U.S. are slowly getting both types of plugs now, because the new Aria takes the CCS. So that's going to be good for just having more access, because the Nissan dealers are in a lot more smaller places. So at least give some charging infrastructure out there to supplement what's being done up and down the interstates. But I think it's what's going to be exciting to see what happens for them as some of the fleet operators have to put more infrastructure in on the roads, at the truck stops and all.
Any additional questions for Van?
That's a lot more information than I thought I was going to get. So it's a lot to unpack. Thank you, Van.
No problem. And I apologize. I'm like a walking collection of sticky notes. Over the since 2012, me and the teams that I ran, we installed upwards of probably 20,000 chargers in 20 different countries, all across the U.S., Canada, Latin America, parts of Europe, Australia. So, which means we made a lot of mistakes. We have scars, bumps, bruises, ulcers, a lot of pain and suffering to put in a lot of chargers for not a lot of vehicles.
Van, everything that you've been talking about, so many of these aspects are things that are coming up on a daily basis with fleets and with communities in Virginia and in the nation. And so I really appreciate your time today. And I hope, I really hope to be getting together with you in the Chesterfield area for some great heavy duty electrification and megawatt charging efforts in the future. Thank you all very much for your time today and for enjoying this technology happy hour.